Welcome to this segment. Well, today we'll be estimating regression model using maximum likelihood. So we start by stating the normal distribution. So this is our normal distribution function. It's given as 1 over 2 pi exponential minus half sigma square. Here is also sigma square. Then followed by error. The E here is the error. Now, because we want to estimate the regression model, so let's see what regression model looks like. This is a regression model. Yi, B naught, B1, Xi plus error I. Now, the next thing we have to do is to make the error the subject in regression model, so we can substitute the value of the error into the normal distribution function. So it's going to be y minus beta naught minus beta 1 xi equal error I. So what we did now is to make error the subject. I know to make anything item subject or quantity, it means you are isolating the quantity. So since we said we are making error the subject, we have isolated the error. Now this is what error is made of, and we are carrying the value of the error, replacing the error here. So it's now going to be f of y, the y function, 1 over 2 pi sigma square followed by exponential minus power of half sigma square. Instead of writing this error, we are putting the value of the error, who is now yi minus b naught minus b1 xi. If you see, the error is raised to the power of 2. So will this one be? So this one is also raised to the power of what? 2. Now, the next is to take the maximum likelihood. The maximum likelihood. The maximum likelihood of the function, that's the what we are taking down. So the likelihood of this function will now be the product sum I runs from 1 to n, the product sum of the likelihood of the parameters here. Who are the parameters? Sorry, we have who are the parameters? We have b naught. We have b naught as one of the parameters. We have b1 as parameters. We also have sigma square as a parameter. Now we are now going to work this sum of products or product sum on this. So let's see what product sum looks like on this model. So it's going to be this. We start with this one. 1 over root 2 pi root raised to the power of 1 followed by, now this I comes to 1, xi comes to x1 raised to the power of 2. Sorry, raised to the power of 2, yes. Times, we are doing this again. So 1 over 2 pi this. Remember, the first one is raised to the power of 1. Second one is raised to the power of 2. Followed by this. Then now I'm going to have y2 Here used to be B naught, so it will remain B naught. So this is still B naught. Then this is x2 raised to the power of 2 times, and so on, because we will not continue. Where will you stop if you continue? So the next one is going to be 1 over root 2 pi sigma square raised to the power of n, followed by exponential this raised to the power of yn, not power, followed by this yn b naught xn. Now, this is what this sum product is all about. You multiply and be unnecessary. Now, looking at what we have now, considering this one, this, if you bring it together using indices, according to the law of indices, under multiplication, add up their powers. So you see that the bases are the same, because that we don't know the true value of these powers. So we now assume that the sum of the powers now, so this is our the likelihood function of b naught, b1, and sigma square. So the result from this is as good as this. So when you bring their sum, we will have this 2 pi raised to the power of n. So this is raised to the power of n. Then what about these people? If you notice here, the changes were happening inside the bracket. Inside the bracket. So we are going to have exponential minus 1 over 2 followed by sum of irons from 1 to n brackets yi minus b naught minus b1 xi raised to the power of 2. Raised to the power of what? 2. So this is where the summation happens. This is the changes we are recorded within the bracket. So putting all these people together is as good as saying they are sum of this. Now that we have done this, let's use indices to rearrange it before we can take the logarithm. So the likelihood function of b naught, b1, sigma square. Here, what we have here is as good as 2 pi raised to the power of n minus n over 2, using negative index power and fractional index. These are laws of indices. The next one is, so this will give birth to this. If we know our indices very well, we should be able to rectify this. Then we now have this. This one here is as good as saying minus irons from 1 to n raised to the power of 2. So it's the same thing. All over 2 sigma squared. This is coming here, they are the same thing. So next is to take log of both sides, and we are taking log, the natural logarithm, log of base e, which is the same thing saying ln. So ln likelihood function, this log of this is minus n over 2 ln 2 pi. Then the next one is n over 2 ln sigma square. Then remember that this is e, and we are doing log e. So when we have log EE, because this one will come here now, log EE is as good as 1. Why this one as a power will come down? So I'm going to have minus yi b naught b1 xi power of 2 over 2 sigma squared. Now that we are taking the log of both sides, next is to take the partial derivative. So I'll be taking my partial derivative with respect to b naught. I'll be taking this with respect to b naught. So it's going to be partial derivative of ln of this the partial derivative of b naught. And one thing about partial derivative is that when you want to differentiate, like the partial derivative is with regards to what? B naught. If you come where there is no b naught, everything about them turns to 0. So coming here, I have minus. Trying to differentiate this, there is no b naught, is 0. Followed by another minus. Trying to differentiate this, there is no 0. So, there is no b naught. Here comes another 0. Now, what I have, I'm having a power here. This we call for function of function. Differentiation by function of function. Though, we can still do it this way. Watch. The power comes down to multiply here. I'm having minus 2. Sum of I moves from 1 to n. Remember that 2 times invisible minus 1, we have minus 2. You subtract 1 here. You are left with power of 1. Everything all over this. Now, because we are differentiating with regards to b naught, if I differentiate b naught, what am I meant to have? I'm meant to have minus 1. That minus 1 is this. What I have done is function of function. Like a short way of doing the function of function. Okay, so this 2 can cancel this 2. Minus 1 times minus this, of course, is positive. And the result of the differentiation will be equated to 0. So I'm now left with n, sum of I ranges from 1 to n, equals 0. Remember why we are not having negative here, because minus 1 times minus 1 here gives plus. So all over sigma square. Now, if I cross multiply here, sigma square times 0 is still 0. So I'm left with yi b naught b1 xi all equals to 0. Now, what happened again? If I open bracket using this, I'm going to have y, the mean of y. Here I'm going to have cap of b naught, b1 cap, followed by mean of x equals 0. And because I'm working on b naught, so I'm going to make b naught the subject. So this is now, I have y bar minus estimate of b naught, which is this. Estimate of b1, the cap indicates estimate. Now we now have y bar minus b1 bar mean of x equal b cap naught. So this one alone is for with the partial derivative with regards to b naught. We are expected to do the same for b1 and also for this last parameter, which is sigma square. Thank you for watching. God bless you. Do not forget to share this video.